Welcome to Daily Physics Lecture 8. In the previous lecture, we have discussed about Kirchhoff's law and we discussed what types of question may appear from Kirchhoff's law. And today, we'll discuss about why we can use this Kirchhoff's law or why this law is so important for solution of different kinds of circuit. So before solving different kinds of circuit, there are several things that are important. We'll discuss this now and then we'll try to solve single loop circuit by using Kirchhoff's law. So let's start the class. If we want to use Kirchhoff's law in a circuit, then there are three things. Those are very important for a circuit. We have to understand those three things first. So what are these three things? Let's take a look. So these are three things: junction, lines, and loops. Though we are familiar about these words, but it is really confusing when you try to solve a multiple loop circuits by using Kirchhoff's law, that what are the loops, what are the lines, and what are the junctions. So let's draw a circuit and let's see. Now let's see this circuit. This is a very simple series circuit. Simple series. This circuit contains one loop. Okay, loop means closed line. Loop means closed line. This circuit contains one loop, and this is a single loop circuit. Single loop circuit. In case of a single loop circuit, the number of loops is 1, and as the loop is 1, so it only contains one line. So maybe it's a closed circuit, and if I assume it's a rectangle, then it may have 4 different arms or sides but one line. So these line, these line, these line, and these line are not different. So this is the same line. So we have only one line in a single loop circuit. So as we have only one line, the whole is one line. So we have only one current. So number of line also indicates the number of current flow. So only one current will flow through this circuit. As we already know that in a simple series circuit, only one current flows. So we have one line, one current. And what about junction? Some can say that there are three junctions. These, and these. These are junctions. Some can say that. But these are not junctions. These are the edges. So what are junctions? Junctions are the intersecting point where more than two lines intersect. These are not the intersecting point. These are basically the edges of a single line. So here this is only one line. Maybe this bending, but this is only one line. So this line doesn't have any junction. So this is one loop, contains one line, and it doesn't have any junction. So I hope you understand the loops, lines, and junction for a single loop circuit. So let's try to discuss about something different, a multiple loop circuit. So now this is another circuit and this is not single loop, okay? So here you can see that there are more loops. So let's start with the junction first. How many junctions are here? Now you can see that this point B, C, these are not junction, these are edges, okay? E and F, these are also not junction, these are edges. But the junctions are point D. Look, point D is a junction. That's point D. So 1, 2, 3 line are here. So point D is a junction. And so we have junction D, and this point A, this is also a junction. So from here, what can I write? This is point A. We have 1, 2, 3. 1, 2, 3 line. So as there are 1, 2, 3 line in, and this is the intersecting point. So A is a junction. So here in the following circuit we have two junctions, and these junctions are D and A. Please remember, B, C, E and F, these are just points, not junction. Okay, point and junction are not same. So in a particular point where more line intersect, this is known as junction. But if it's just a bend of a line, of a single line, not the intersecting point, then these points are known as edges. These are not junctions. So here in this loop we have two junctions, and the junctions are D and A. So now how many loops are here? Loops means closed line. Okay. Now as you can see that there are two loops like this, A, B, C, D. That means this part, the left side, A, B, C, D. That means A, B, C, D. Okay, one resistance, one cell, two cell, one resistance, one cell, two cell. So this is loop number 1, and at the right side we have A, F, E, D. A, F, E, D, which also contain two cell and one resistance, two cell and one resistance. This is another loop. One close line, two close line. So we have two loops. Are there only two loops? Though it looked like there are two loops, but actually there are three loops. Why? Because we forget about B, F, E, C. So this is the third loop, which is B, F, E, C. B, F, E, C. So this is loop number 3. So this circuit contains 3 loops. This is one loop, the left side small loop, this other loop, the right side small loop, and the third loop is the whole loop, the total one. So there are 3 loops. So number of loops are 3 for this circuit. Loop number 1 is A, B, D, C, D, A. This loop number 2 is A, D, E, F, A, and loop number 3 is B, F, E, C, B. So there are 3 loops. Now the problem is then how many lines are there? Why? Because line will give us the idea about how many current will flow through the circuit. So defining line, I want to give you one shortcut. Line always start from a junction and end at other junction. Please memorize this part. Line always start from one junction and end at other junction. So if you look at this circuit, this is junction number 1, junction number 2. So how many lines are here? From A to D. This is one line. A is the junction, D is another junction. So this is one line. And here at the middle, A to D. This is the other line, line number 2. And here at the right, AFDE, AFED, sorry, AFED. that's the other line. So there are 3 lines, and all these lines starts from A and ends at D. So this circuit contains 3 lines, and the lines are ABCD one line, AD another line, and the third line is AFED. So there are 3 lines: ABCD, AD, AFED. So A to D, A to D, A to D. So there are 3 lines. So as there are 3 lines, which means this circuit contains 3 currents. I already said that the amount of current flow is equals to the amount of lines. So if we have 3 lines, that means there are 3 current flow. So these are important for a circuit. Now one more thing. So this is another circuit, though it look like pussycat type, but this is a circuit. And if I ask you the same things, how many junctions are here? Junctions are the intersecting point. This is not 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 intersecting point. But here, this point E is an intersecting point. 1 line, 2 line, 3 line. So 3 lines intersect here. So this is a junction. So we have found junction as E. Now C is also another junction. Why? Because 1 line, 2 line, 3 line. 1, 2, 3. 3 line intersects here. So this is another junction. So we have 2 junctions here. One is E and another one is C. So let's see how many lines are here. So what are the lines? Lines start from a junction and ends at other junction. Okay. So according to this, C is one junction, right? C, B, A, F, E. C is one junction, E is other junction, right? And lines start from one junction to another junction. So C, one junction, C, B, A, F, E. C, B, A, F, E. So this is one line. C, B, A, F, E. This is one line. Now, what about the other line? C, D, E. C, D, E. This is the other line. And what are the third line? C to E. This small one. So now, as C and E, these are the 2 junctions. So how many lines are here? All lines will start from either C or E and ends at either C or E, or vice versa. So here the first line E, C, B, A, F, E, that means this one start from C, ends at E. The second line C, D, E, this line starts from C, ends at E. And the third line C, E, start from C, ends at E. So there are 3 lines, which means there are 3 current flows. How many current flow? 3. Now let's move into the how many loops are here. Okay, let's take in how many loops are here. So this is one loop, this is other loop. We can always identify this part. So E, F, A, C, A, B, C, E, the left loop. And left loop is, if I start from E, E, F, A, B, C, and again E. So E, F, A, B, C, E. That means this rectangle is one loop. Okay? And other loops C, D, E, C. As it's a loop, that means closed line. So if it start from C, it will end at C. So C, D, E, C. C, D, E, other line. Okay, and what about the third loop? The third loop is the whole one. And what is this whole one? If I start from this E, then E, F, A, B, C, D, E. So this is the third loop. It starts from C, E, F, A, B, C, D, E. That means this one, the whole one, actual. Okay, so now I understand you have got the idea about the junction, line and loop. So this is here, this is very important. Another thing, when we try to use the Kirchhoff's law, the first law, or which is also known as the junction law, can be applicable only for junctions. Okay, this is the first thing. The second thing is that the second law, summation of E is equals to summation of IR. It's called loop law. So this law can be only applicable for the loops. So here, as this circuit contains 3 loops, 1, 2, 3, so we can use this loop law 3 times, as we have 3 loops. How many times we will use it, that's all about us. But we can use up to 3 times, as we have 3 loops. So we can use the loop law 3 times. We have 2 junctions, we can use the junction law 2 times. And now, what about lines? Lines indicates the current flow. If we have 3 lines, it means 3 current flow. If we have 1 line, means 1 current flow. If we have suppose 6 lines, that means we have 6 number of current flow. Okay, so now we'll try to understand the Kirchhoff's second law further clearly, so that we can solve it in our problems. And there are some steps where we'll discuss it now. Okay, let's discuss about the techniques of using Kirchhoff's law for a circuit. Suppose we have this circuit, this very simple series circuit, and this circuit contains one cell, 1, 2, 3 resistors. And how we define the current flow? By knowing the direction of cell. So as this is the positive side and this is the negative side of the cell, so we know current flows from positive to negative. So this will be the default direction of current flow, right? But this only applicable for one cell scenario. But what if we don't have one cell, rather than we have more than one cell, and their directions are arbitrary? Suppose we have 2 cells and both are acting along the same direction. This is the positive negative and this is the positive negative. So for both cells, the positive direction is towards left and the negative is our right. So we can also say that this will be the direction of current flow, as both are acting towards this direction. But now, what if we have more than one cell and they have different directions? Just like the direction of this cell, the positive side is towards the right side, so it will try to let the current flow towards that direction. And for this cell, the left side is our positive direction, so these will try to let the current towards the other direction. Now that's the problem. So for these types of scenario, if we have more than one cell and the direction of the cells are different, then this is tough for us to identify the actual direction of current flow. Now here we have 2 cells. Now here we have 2 cells and 1 resistance. So we do know the direction of cells because we know this, the positive side is this side and this is the negative side, and this is the positive and this is the negative side. So we can identify the direction of EMFs for each cell. Suppose this is the E1 and that's the E2. Now, at which direction the current will flow? As we know about the game where one rope and two teams remain present and both try to rope towards their individual direction, I'll go for that types of scenario. Okay, so let's assume here we have two group of people and this is the rope, this is the group 1 and this group 1 is trying to pull the rope towards this direction, and this is the group 2 and they are trying to pull the direction a rope towards that direction. Okay, so these are their direction of pull. So we do know the directions of their pull by seeing themselves. So if I am an audience and I am just watching this game from this sport from the gallery, then obviously I do know that the group 1 is trying to pull it towards this direction by seeing their faces or direction, and group 2 is trying to pull the rope towards that direction. So let's assume these groups are like cells and this pull is just like EMF. So the cell 1, by seeing the direction of the cell, is trying to pull the electrons towards this direction. So this is the direction of E1, and cell 2 will try to pull the rope pull towards the other direction. So direction of EMF of cell 2 towards that direction. But what we don't know is the direction of current flow. And obviously, let's move into here. We have a cat here. So let's assume what is the task of the cat is. It will remain stationary above the rope. It will not move. So at which direction the rope will move, the cat will move towards that direction. So we can say the direction of their individual pull, but we can't say the direction of the movement of the cat. Why? Because we don't know who is applying more pull, right? So the direction of the movement of cat is not known to me from the diagram or from the figure. So though we know the direction of EMF by seeing the cells, but we don't know the direction of current flow. So what will we do? Obviously, if there are multiple amount of cell in a line, but in a line that means one current, so what will be that current? Obviously it will flow in a particular direction, but what will be that direction? There are possible two directions, but we don't know. So there are some conventional rules for assuming these directions. So if we go for solving a circuit by Kirchhoff's law, there are several steps, and now these steps will be easier for you. The step number 1, you have to name different points. We have already discussed it in case of the in junction, line and loops section. And step 2, what we have to do, assume the direction of current, assume current directions in lines. This is very important. As I already told you that we do know the direction of EMFs, but we don't know the direction of current. So from the second step, we have to assume a direction of current. So let's assume the current is flowing towards that direction. We assumed it. So this should be the direction of current flow. Okay, we already assumed it. So you know the direction of EMF, but you have to assume the direction of current flow because you don't know it. So step 2, you have to assume the current flow. And now we have a lots of directions. We have E2 there, we have E1 there, we have I there. So there are lots of directions. but basically there are two directions, that or these. But we can't take all directions as positive, right? So we have to assume one direction positive. So the factors which are working towards that direction will be positive, and the factors which are acting towards the other direction will be negative. So here, this step 3, you have to take some default direction as positive. It can be clockwise or it can be anti-clockwise. So let's assume this direction as positive. Suppose that's the clockwise direction. This is I assumed it as positive direction. So I will be positive, E2 will be positive, but E1 will be negative for this line. I will be positive, E2 will be positive, but E1 will be negative. I hope you have understand the step 2 and step 3. For step 2, you have to assume a current direction. It's all about you. And step 3, you have to assume a default direction as positive. Okay? But it is better for Kirchhoff's law to assume the default positive towards the direction of currents. Okay? So always try to assume the same directions of current and positive directions. Okay? So let's solve the circuit by using Kirchhoff's law. Okay, so these are the steps. Step 1, naming points. Step 2, they assume the current direction, and step 3, default direction, either clockwise or anti-clockwise. So here this is a circuit, very simple circuit. We have 1, 2, 3 cells here, and we have 2 resistors. As it's a single loop circuit, so obviously we have one line and one current. Okay, as it's a single loop. So now let's use the steps. Step 1, naming point. For single loop circuit, it's not important to go through step 1, start with the step 1, because we have only one loop, so we don't need to define the loop, because we already know which one should be our loop, because we have one loop only. So let's start from the point 2. So as we have the directions of currents are in different orientation, the direction of, as we have the direction of cells in different direction, so we have to assume the current flow. It can be this direction, it can be this direction, but as it's a one line, so one current flow. We can have 1,000 cells, but current will be 1. So let's assume a name. So let's assume there are 2 directions, clockwise or anti-clockwise. So I assume the direction of current as clockwise and named it as I. So that's the I, as it is one line, so I, it will be I, all are clockwise, all are I. Okay, I already completed step 2, I already named the current flow and identified the direction of current flow. We assumed it. This is not given, I assumed it. Step 2 complete. Now step 3. Let me tell you, step 2 is all about you. So you will assume your direction. It's not important what I am assuming, it's all about what you are assuming. Now step 3, default clockwise or counterclockwise. So now you have to take one direction as your default positive. Okay, so as I've already assumed the clockwise direction as I positive, so let's assume the clockwise direction as default positive. There is a shortcut. So it's better to assume the positive direction as the direction of your assumed current. Okay, so it's better if you assume the clockwise direction for current as positive. Let's assume the clockwise direction of as your default positive. Okay, the direction of current flow and direction of default positive. If you take these 2 positive along the same direction, then it will be easier, not necessary. step 3 complete. We assume the direction of current flow. We assume our default positive as clockwise. So now all these steps are done, but we don't get the current flow, right? So now we know for a single loop circuit we do not have any junctions, so we can't go through Kirchhoff's first law because it's a junction law. We don't have junctions, so we can't use Kirchhoff's first law. But we have a loop, so we can use the Kirchhoff's second law. So step 4 for single loop circuit, Kirchhoff's second law. Summation of E is equals to summation of I. Let's use it. This law. So here at the left side we have the summation of E's. So we will sum the EMFs. Okay, EMFs comes from cell. So let's find out where are the cells. Here, here, here. We have 3 cells. So now those will act along the clockwise will be considered as positive. Those who act along the anti-clockwise will be considered as negative. So let's start with these 10. Here one more important thing. When you try to write down the left side, that means the EMFs, please imagine that circuit doesn't have any resistance, circuit doesn't have any current flow. There is no resistance in the circuit, I already imagine it, and there is no current flow. Only cell and only EMF, because I am trying to fill up the left side. So we don't have any resistance here, we only have cells, 3 cells. I am imagining. So here, this is the 10. We don't have current flow, so let's forget about this I. 10. We know the positive direction of our cell is this and negative direction is that, right? So this is the positive, this is the negative. So this cell will pull the electrons towards this direction, the direction of this marker. Is it a clockwise or counterclockwise direction? Okay, so my hand is the needle of a clock. Suppose this is the second hand. So now if there's a tail and there's the pointing, that's the direction of the cell. So tail to pointing, if I move from tail to pointing, tail to pointing, tail to pointing, so if the hand moves like this, so this is the clockwise direction, right? This is the clockwise direction. So direction of this cell is clockwise direction. And our default is clockwise too. So this 10 volt is a positive cell. And now let's think about this 5. That's a positive, negative. So that's the direction of 5 volt. So again, this hand is just like the. Let me move towards this direction. This will be better. So that's 5. So this is the second hand of a clock. So that's the tail and that's the pointing. So negative side, positive side. So that's the direction of our cell, right? So tail to pointing, tail to pointing, tail to pointing. These. So this is like this directions movement, right? Like this. So this is clockwise. So this 5 volt cell is acting along this direction. So this 5 volt is acting clockwise, and our default positive is also clockwise. So 5 volt is a positive cell. And now let's move into this 20. There's a plus and there's a minus. So this should be the direction, right, towards the plus. So here, this is the tail and that's the pointing. So this hand is my second hand, this hand we assume it's the second hand of a watch. So tail to pointing, tail to pointing, tail to pointing. So this direction. This is not clockwise direction, right? That's the anti-clockwise. So the direction of this sail is anti-clockwise. But our direction, our default positive direction is clockwise. The direction of this sail is anti-clockwise. Positive to negative. Positive to negative. Anti. This is the anti-clockwise. So direction of this 20 volt is anti-clockwise and our default positive is clockwise. So this 20 is a negative cell. So we are done with the left side. Now we have to move at the right side. So for the right side, forget about the cells, look into the resistances. So we have 1 and 2 resistance. So through this resistance, the value of this resistance is 10. Write down 10. We have no problem with this resistance because resistance doesn't have polarity. And we have I into R. So we have to multiply the current flow. So through this 10, I amount of current is flowing. So write this I. And now try to figure out the direction. So that's the direction, right? Look, the direction of I is that direction, right? So current will flow like this, like this, like this, this. So that's the clockwise direction. So this current through 10 is a clockwise. Our default positive is clockwise. So this current flow is a positive current. We need not to write the positive sign, right? So let's move into this 5. The current flow through 5 is this direction, right? So this will move up. So that's the clockwise, right? So current flow through 5, that means I into 5, this is also clockwise. So in the series circuit, in the single loop circuit, as we have one line, so how many resistors doesn't matter, we have only one current flow. So it is better to assume the direction of current flow and positive direction same, so that all current will be positive. So now if I solve it, here at the left side we have -5 and at the right side we have 15I. So which means I is equals to minus 5 by 15. So now that's weird. The value of I is negative. A vector can't be negative, right? If I say that I am moving towards this direction with minus 5 meter per second velocity, minus 5 meter per second velocity, so that means I'm telling lie. Minus 5 can't be value of velocity. So I am moving towards this direction with minus 5 means I am not moving towards this direction. I am actually moving towards the opposite direction, right? So if as I assume the current flow as clockwise and I found the value as negative, that means current is actually not flowing clockwise, current is rather flowing anti-clockwise. So minus means our assumed direction was wrong. So finally at answer, I will write the value the minus at answer I will write 5 by 15 ampere towards anti-clockwise. Okay, because from negative sign we assume we have found that the current will not flow towards the clockwise direction, which we choose, the current will actually flow towards the counterclockwise direction. So that's the end of today's lecture. I'll give you some homeworks, please solve this. And this lecture is very important, not this single loop circuit, but it's important for the discussion we have done before it. So from this lecture, what are the important topics is? The initial topics is what are junctions, what are lines, what are loops. This is very important, especially for multiple loop circuits. And the next, how many steps are there? So there are 3 steps, we have to name it, we have to assume the direction of current, and then we have to choose a default positive direction. So whatever the type of circuit is, whether it is a single loop or multiple loop, we have to go through these points and we have to go through those junction, loop and line. So from the next, in the next 3 lecture, we'll discuss about the multiple loops Actually, multiple loop is important for credit. Single loop problem is less important for credit. Unless you are very lucky, it will not appear in example. But this is important for MCQs, and if you are lucky there. So please watch this lecture again and again so that you can memorize those steps and those things properly and share it and solve the SWs. And today's lecture is important for the next 3 lectures. So this is for today, and please remain in your home, don't move outside. This situation is not good here in our country, and I will pray that all of you will remain okay, and you will be okay in future. So pray for me too. Thank you. See you tomorrow, and Allah Hafiz.